Section 9.1 is going to start working on hypothesis tests for two population proportions. So what you're going to find in Chapter 9 is that we're moving on from just dealing with one sample to dealing with two samples. Now that's going to become an important little detail to pay attention to as you work through your problems, because eventually you're going to be, laden with all kinds of different hypothesis tests. And you have to decide, well, which one do I want to do? Not yet. A little premature on that one, but we're going to be testing two population proportions. So that's going to mean at some point or another, P1 equals P2, or less than or equal to, or greater than or equal to, etc. Remember, that's all going to go in the null hypothesis. So you're going to start by stating the null and alternative hypothesis. The null hypothesis, I can't emphasize this enough, is going to contain parameters. So your parameters up to this point are mu, p, and sigma. And your null hypothesis should contain less than or equal to, or greater than or equal to. Your value of alpha is going to be given to you. That's not something you're going to have to typically decide for yourself. If you did have to decide a value of alpha, typical values are what? Yep, 0.05 and 0.01. So those are your typical values. Now you're kind of lucky because we're using some technology. We don't have to do this kind of the old school way. I like the p-value approach that we're going to do. So for us, our step 3, instead of finding these critical values and then calculating the test statistic, and this becomes kind of tedious here, instead of all that, we're just going to input some summary values into StatDisk and then look for the p-value from StatDisk. So where you're going to have to go, well, I think you can tell me a little bit about where you have to go in StatDisk. Where are you going to, what menu you're going to look at? Analysis. Good. So analysis, and then hypothesis testing. And from there, two sample proportions. So that's where you're going to go under StatDisk. The analysis menu is going to get 98% of the work done that you need in this class. Once you have a p-value, then you need to make your decision. So how are you going to make your decision? When do you reject based on the p-value? Yep, if p is less than alpha, then reject H0. Nice. After that, you're going to use your wording the hypothesis conclusion handout to finish this up. If you've lost yours, then you can get another one off of D2L. Just go to the content section and do a search for wording. You'll find it. So as a quick little reminder here, let's take a look at wording. Should look like this. I will let you use a copy of this on the exam. So you don't have to really stress about this. If you've got a copy, that's great. I'll print off a few extra ones. Just make sure that there's nothing else on it. I don't want any other notes or anything like that. You can put your name on it, that's fine. But do have that around for yourself for the exam. Now, there are a couple assumptions that we're going to have to make in doing this test. We want independent samples. What I get from one sample is going to be independent of another sample, and the number of successes and failures for each of these has to be at least 5. So those are a couple sample or assumptions. Let's start with example A. So I'll pull it up here. Now this is actually something that is a little bit less generic than what they have here. Here they just talk about a large clinical trial. The actual study that they're referencing is the one that established the effectiveness of the Salk vaccine for polio. Now polio is not something that's in most of our experiences. This was wiped out decades ago. Fortunately, it was really a really terrible disease, very crippling, etc. The actual analysis of the data was done at the University of Michigan. I think Johannes Salk might have worked at the University of Pittsburgh. He's where they developed it. But in any case, let's actually run through a simile of the data and see what it says to us about the Salk vaccine. So in a large clinical trial, 399,062 children were randomly assigned into two groups. The treatment group consisted of 198,630 children given a vaccine for polio, and 35 of those developed disease. The other 200,432 children were given a placebo, and 122 of those developed disease. So there's a lot of stuff going on here, but we're just going to run through a hypothesis test. Now, a lot of times we can also do a confidence interval in association with our hypothesis test, and occasionally your confidence interval and your hypothesis test tell you different things. If they do, then side with the hypothesis test. Hopefully they say the same thing. If you have to make a choice, go with the hypothesis test. So let's take a look at example A. Now, a lot of times I like to give myself some notation for these things rather than just deal with P1 and P2, which is what you're going to see in your assignments and things like that. Either way, no matter how you label it, you do have to keep track of things. So let's get started with example A. To me, P1 and P2 just doesn't, help me navigate my way through the problem. It just doesn't look right. So let's give this some more descriptive terms here. Let's see. We're going to test the claim that, where is it? At the 5% significance level, test the claim that P1 is less than P2. Basically, that the treatment group is less than the control group. I like those better, so let's go with that. Let's start out with the claim that P sub T is less than P sub C. You can use P1 and P2. It's up to you. With that as our claim, try and fill in the null and alternative hypothesis. Okay, Steve, start us off, please. What would the null and alternative hypothesis look like, please?
Alternative, it would be less than the control group, and then H0 would be greater than or equal to the control group.
Good. So you've got the group that got the vaccine, the treatment group, has a proportion at least, so or greater than or equal to the control group, and the alternative hypothesis is that the treatment group gets polio at a rate less than the control group. So let's take a look. That's step one. Step two. I don't know. So do they give you an alpha in this one? Yeah, 0.05. So alpha is 0.05. Step three, we got to be a little bit careful when you input things. When you input things into StatDisk, it's going to assume that this is your first group, or sample one. Sample one. And this is sample two. So we're going to kind of have to keep that straight as we move into things. Now the assumptions here are that you have independent groups and that each group has at least 5 successes and at least 5 failures. Well, our numbers do coincide with that. So let's go into StatDisk and enter some of this data. So stat-disc, analysis, hypothesis testing, and then proportion to samples. The first thing you have to do is you have to decide, what's going on with your alternative hypothesis. All right, so do I want 1, 2, or 3 for my alternative hypothesis? What's looking good? Yeah, 3. I want a less than. So population 1 is less than population 2. Population 1 has all my data from the treatment group. So let's go back and enter that population data. Let's see, it was 198,630. So 198,630. And of those, 35 children came down with polio. Our other group was 200,432, and of those, 122, was it? 100, 122? Okay, good. So, I think that's it. We're looking good there. We've got our alternative hypothesis set up in the right direction, so, bam. Enter that, and let's see. What information do I need here? Yep, I need the p-value. So that's step 4. Step 3 was the enter the data. Step 4, our p-value is essentially 0.
0.0000.
Yeah. Thank you for that correction. 0.0000. Yeah. All right. Looking good. So, Oz, with that as a p-value, what are we going to decide in step 5? What's our decision going to be?
Our decision is going to be.
It's okay. Stall for time. Stall for time.
Can I phone a friend?
You can tap a friend to your left or to your right.
You would reject
All right.
H naught.
Good. Reject H naught. Why?
Why we can't fail to reject it? P-value is low, H naught must go.
Yeah, our p-value is less than alpha. So when your p-value is less than alpha, you're going to reject H naught. So cool. Reject H naught. Let's go back and remind ourselves something. This is our original claim right here. Why do I need to know that? What difference is that going to make?
So we know what we're rejecting? Exactly when we put it in our. Okay, reject the alternative.
Nate? Why do we need to know our original claim? Some help? Anyone? Bag of M&Ms. Oh, man, I pressed the right button. Yeah?
To explain and work.
Yeah, we need to know that so that we can decide what the form of our wording to conclusion is. So let me go back over here, my wording to conclusion sheet. The first branch says, does your original claim contain the condition of equality? No, it doesn't. So our original claim had a less than sign, not a less than or equal to sign. So that's our first branch. We branch down here. Do we reject the original claim?
Yes.
Yes. So the sample data support the original claim, and then you have to say that original claim in words. So let's see if we can't do that. You want to give it a shot first and then compare your answers to mine? Yeah, I like that idea. All right. So give that one a shot. If you're watching this later, then maybe hit the pause button for yourself. Man, I don't have a pause button right now. I have to make a new pause button. All right, so pause. I know, it's pretty high tech, isn't it?
Can you move it down some? No, the pause button. There we go.
you keep them. I mean, I think with your background comments, it's going to send the number of likes I get on my videos into the double digits at least.
I like every one of your videos, sir.
I
Yeah.
subscribe to you.
Actually, I am looking for my 500th subscriber.
Oh, okay,
So,
great.
yeah,
Okay.
pretty exciting.
I'm gonna unsubscribe and then wait, and then I'll wait.
What do I win if I'm your 500?
What do we get?
I don't know. That's a good question.
Hey, I ain't even greedy. If you give me a B minus, if you give me a B minus, I'll get you 500 right now.
So my threshold for taking bribes is that I have to be able to retire comfortably.
Oh,
So, yeah, I don't think $500 is going to do that.
not $500, 500 followers.
Oh, so you're going to be my 500th. That you're going to work that hard to get a B. Okay.
No, I said I can get you 500. Please don't do this.
500 more?
Yeah,
All right.
I can get you up to 1,000, man. All it's gonna cost you is $2. Here you go, Phil.
All right. So let's see. Who wants to try their conclusion? Edmund?
The
Bless you.
sample data supports the claim that children with the vaccine get polio less than kids without the vaccine.
Great. Sounds good. So anyone else want to try theirs? There's certainly a variety in the answers that I would accept. But that was a good example. Sample data support the claim that the proportion of children that get polio amongst people with the treatment group is less than the proportion in the placebo or control group. Another one. Anyone else want to try theirs?
Can you
All right.
repeat it again? I struggled with this too.
So what I would suggest when you're setting these things up is you start out with the first part that's more or less given to you by your handout, sample data support the claim that, and then you want to state the original claim in words. Now, the original claim was that P sub T is less than P sub C. The proportion of people who got polio in the treatment group is less than the proportion of people that got polio in the control group. So, yeah. Now, the proportions were really small because polio was rather an uncommon disease, but it was also very, very crippling, which is why there was such an effort to eradicate it. If you did look at it, the treatment groups were roughly the same size, about 200,000, but 122 cases amongst the control group is more than 3 times as many as amongst the placebo group. So definitely are amongst the treatment group. Cosmo?
You want us to say that we support the claim, not we fail to reject the claim?
Yeah, I don't think that's one of the wordings there, right? Let me take a look back at the sheet. Yeah, there's nothing in the wording here that says we fail to reject the claim. So I'm not sure where that would come in. But I would strongly suggest you use this wording to start out your conclusion. And then, at some point, given that you're going to start with A, B, C, or D, then you're just going to write what the original claim is in words. And the original claim is that the proportion of people who get polio amongst the treatment group was less than the proportion amongst the control group. Okay? All right. Any other comments or thoughts on the first example? let's do a little bit in terms of some notation here. So going back to our original handout for example B here. Let's see, example B. Solve this. Let's figure out what some of this notation is all about. So for instance, it starts out by asking you to find some of these values like p hat. And there's the answer for p hat. But how do you get that answer? Well, that answer, p1 hat, is really, p1 hat is x sub 1 divided by n sub 1. That's all that p hat is. So if you had to calculate some of these statistics for yourself, heaven forbid that you end up having to find the actual z value, then you're going to need to know some of these things, like p1 hat or p2 hat. Now maybe you can take a good educated guess at this. If this is p1 hat, how am I going to find q1 hat? Think back to the binomial distribution. Yep, 1 minus. So q1 hat is going to be 1 minus p1 hat. Yeah, I know. I didn't come up with the notation, okay? I don't know why, but I always think of the French word for hat, like chapeau, but whatever. All right. P2 hat. Again, not so dramatic. P2 hat is going to be x2 divided by n2. And just like q1 hat, q2 hat, go ahead. 1 minus p2 hat.
I did.
I think she did.
Exactly.
All right. So last but not least, there's p bar and q bar. Let's talk about p bar. P bar is going to be x1 plus x2 over n1 plus n2. So kind of like an overall probability. The combined probability of getting polio in this study. Last but not least, Q1 or Q bar is going to be 1 minus P bar. So,
I wanted to do that one.
sorry. I should have reached out to you on that one. My bad.
Next time.
All right. Next time for sure.
Probably.
Let's look at example C, unless there's some comments or thoughts on example B. Just some notation. This is not, a typical question for me. I'm not really interested in quizzing you on this. I want to make sure you can state your conclusions, that you set up your null and alternative hypothesis correctly. By the way, let's go back to example 1 for a couple things here. First of all, when you set up your conclusion or your null and alternative hypothesis, H naught should contain one of these three symbols: mu, p, or sigma. All right. If you put in a p hat or an x bar or an s, you're going to lose points. The other thing I look for is that these symbols are pointed in the right direction. So the first part of this is going to be worth 3 points. Getting the p-value, that's another couple points. Correct decision based off the p-value, that's another couple points. This should be more than a 50-50 chance. I mean, this should be a lock. If this is less than alpha, reject H naught. If it's greater than or equal to alpha, then fail to reject H naught. Well, I'm not sure about the equal to. You're never going to find something that equals to, except there's one contrived example in the homework, I think, where it's actually equal to, and the answer there is to reject. Finally, 4 points for this one down here. So I am putting a lot of emphasis on this. Now, when I grade things, I do give you partial credit. If you had the wrong p-value but the right decision, compare that p-value, and this goes along with this, then you're going to get most of the credit. But try and get it all right. That'll make us both happy. Let's move on to example C. All right, so example C. And the author is pretty good about coming up with actual data. A newspaper published an article about a study in which researchers subjected lavatory gloves to stress. Amongst 219 vinyl gloves, 66% leaked viruses. Amongst 219 latex gloves, 15% leaked viruses. Using a 10% significance level, tests claim that vinyl gloves have a greater virus leak rate than latex gloves. So let's see if we can't start by using some notation for ourselves in this case. So let's look back here. Example C. So we've got two sets of gloves. I'm going to call it P sub V and P sub L. So our original claim would be what? What symbol should I put between these two? Yeah. The leak rate here is greater than the leak rate there. The leak rate for vinyl gloves is greater than the leak rate for latex gloves. So let's set up our null and alternative hypothesis. So HO and HA. And we're going to do this at a whoppingly large, alpha is 10%. I never do 10%. It's 5% or 1%. And I'll also throw out some data here for you. So for our vinyl gloves, we had N was 219, and the probability that they leaked was 66%. That's not going to do too well when we try and put it into StatDisk, so let's talk about that in a second. For latex, again, 219. These numbers don't have to be equal. 0.15. Darn it. Nice. What you're going to need is X sub V and X sub L. We're going to need actual nice numbers for that. But right now all I'm worried about is for you to set up HO and HA. Hattie, what do you think HO and HA are going to be? Yep, HA is going to be the original claim because it doesn't contain the possibility of equality. So that's our original claim. What's going to go in HO? Other right. So pointing to the left, P sub V is going to be less than or equal to P sub L. Now keep in mind that my stat lab doesn't use the less than or equal to or greater than or equal to as part of your answer. So when you go looking for your answer, you're going to have to look at equal to as part of your answer. So it's going to look like this one here. Now they're using 1 and 2 for these things. You know, if you want to use 1 and 2, that's okay. Just make sure that you tell me which one is which. Mia?
So on a test, if we were to put P1 equals P2, would that be considered wrong or is it
No, that's okay, just as long as your alternative hypothesis is set up correctly.
okay?
So on an exam, if you wanted to put P1 or PV equals PL, you know, if you're using 1 and 2, that's fine. PV equals PL, that's fine. Just as long as your alternative hypothesis is correct. That's all I'm really concerned about. Sam?
We can still also put P1 and P2.
You can put P1 and P2. If you're putting P1 and P2, then make sure that you tell me what P1 represents. So if you're doing P1, that's going to be the vinyl gloves. And P2, that's going to be your latex gloves. The important thing to keep straight is, you know, what's here. Because when you input things into StatDisk, this is going to be sample 1. And this is going to be sample 2. So you can put things in any order that you want, just as long as you keep in mind that the one on the left is going to be sample 1 and the one on the left or the one on the right is going to be sample 2. So that does become important. I had a little bit of a snafu with my morning class because they were a little bit unsure. So I want to make sure that you're a little bit more okay with this by reinforcing that sample 1 is the left one, sample 2 is the right one. Now, if you try to put in, say, 0.66 times 219 to get x sub L, 219 times 0.66, then you might be disappointed. I think it gives you 144 and change. And that's just not going to cut it, because you can't have, you know, a number of gloves that worked as 144 point change. It's either 144 or 145. So let's actually get the correct number here. Looks like I got some of it here left, but let me just start all over. So 219 times 0.66, 144.54. So where should I round this? 145. So if you try to put this number into StatDisk, it's not going to like you. So put in the rounded number, put in an integer. Likewise over here, 219 times 0.15. That's going to round to about 33. So those are the two numbers that you need to put in StatDisk to get to your step 4, which is going to be your p-value. So let's look at those p-values, see if we can't figure that out. Let's start with the alternative hypothesis. So where am I at here? Q. Here's my setup here in terms of HO and HA. Take a good look at this because we need to determine how to set up the alternative hypothesis. Do I want 1, 2, or 3 for the alternative hypothesis? 2? All right, 2 looks pretty good. So we want a greater than, so that's going to be the second option there. So we're looking good on that one. Gave us a p-value of 0.10. All right, that's not too bad. It's actually kind of on the big side, but we'll go with that. N was 219. And we had 145 latex gloves working. And then 219 again. This time we had 34 that worked. Now before I hit the, or 33, before I hit the button here, let's think about something. Do you really think we need a test to prove that latex gloves work better than the vinyl gloves? No. I mean, it should be abundantly clear. What do you expect, before I look at the p-value and stuff like that, what do you expect? Are we going to reject H0 or fail to reject H0? Reject. Now that's going to mean our value of alpha is going to be less than 0.10. Now the smaller your p-value is, the more confidence you can feel in rejecting H0. So the smaller the p-value is, the smaller and smaller chance it is you're making a type 1 error. So, okay. Now let's find our p-value. And it's all zeros again. Here's the thing. This is a chance for you guys to catch a mistake. Suppose you set up your alternative hypothesis in the wrong direction. Now take a look at my p-value. 1. That's basically saying, yeah, we think H0 is true. All right? So if that was the case, boy, that'd be really flying in the face of your data. right? I mean, you're looking at this and you're thinking, yeah, this should be true all day. But if you got a p-value of 1, that would be saying something much different. So maybe look back at the form of your alternative hypothesis to figure out, what's going on there. So our p-value is 0.0000. And what's that say about H naught? Yeah, reject H naught. Now you can look back at your original claim. There's your original claim. Let's figure out how we're going to word our conclusion. So word our conclusion brings us back to here. So quickly figure out which one are we going to use. Are we going to use A, B, C, or D? C. Our original claim does not contain the possibility of equality, and we rejected H naught. So the sample data support the claim that and this is going to get a little wordy here, but there's not much I'm going to do about it. The virus leak rate for vinyl gloves is greater than that of latex gloves. So it is a little bit wordy there. I apologize. But look, of the points on this problem, about a third of them come from right here. So get this part right. Don't try and go cheap on that for me. Edmund?
So with the conclusion, there's sufficient evidence to support the claim that vinyl gloves leak more than latex gloves. Would that be acceptable? Or is there
That's saying essentially the same thing. Sure. Yes. Ian?
How do we know when to put the original claim in HO compared to HA?
Well, the original claim did not contain the possibility of equality, right? So if it doesn't contain either a less than or equal to, or greater than or equal to, it's going to go in the alternative hypothesis. These three, they all go in the null hypothesis. So any one of those means you're going to put it in HO. All right. So since this didn't, that's why it went in the alternative hypothesis. Good question. Now I got a lot of questions from my morning class about the exam you have next week. There's a couple ways I can structure these tests. Let's talk a little bit more about this particular problem and take a look at something that we can do. Let's see. So let's take a look at our H naught, and I'm going to use this form of H naught. PV equals P sub L. Let's look at PV equals P sub L. If I was to subtract PL from both sides, what am I going to get on the right-hand side? 0, right? 0. Now on the left-hand side, these aren't like terms, so I'm just going to get PV minus PL equals 0. So an equivalent way to write this null hypothesis is that PV minus P sub L equals 0. If the difference is 0, then those two things have to be equal. Let's see what a confidence interval says for the difference in these two proportions. Let's see what it says for us in our data. So where am I going to go to find a confidence interval? What do you suppose I have to look at? Analysis. Oh, and there you go. Confidence intervals. Proportion to samples. So I need to type in some more data here. That data for our first sample is 219, and then 145, 219, and 33. Confidence level, 95%. Actually, I guess I should do something other than 95%. Let's take a look back. We had alpha as 10%. So what's that mean my confidence level is if alpha is 10%? 90. So we'll do a 90% confidence interval there. So let's make that a 0. And bam. So there's our 90% confidence interval. So let me copy that down. Our 90% confidence interval is going to be between 0.450, 4450, 550 is less than P1 minus P2. That was less than 0.57733. All right, I don't need all those digits. It's good enough. Okay. Now our decision in the previous problem, or in this problem, was to reject H naught. That's what we decided back here because we got a p-value that was less than alpha. Is this confidence interval consistent with that decision to reject H naught? Are these things saying the same thing? I got a no and a yeah. Why no? Why yeah?
The range doesn't contain 0.
Ah, there you go. That's putting a nice fine point on it. This range doesn't contain 0. If it contains 0, then we would think this is true, which is the same thing as saying this is true. So our decision actually matched what we decided with the null hypothesis. We rejected this because 0 wasn't one of the possibilities. So there's a couple ways I can ask questions on an exam. I could give you some summary statistics like this and say just do the test. That's something you should probably reasonably expect. Or I could give you a p-value and let you decide things based on the p-value. Or I could give you a confidence interval and ask you to make a decision based on the confidence interval. So I don't necessarily need to make you use StatDisk on an exam. I've got a couple alternatives. So I would just be aware of all of them. But chances are you're going to end up putting in some data into StatDisk. We'll just kind of see how it goes. Comments or questions on example C here, kind of the extended version?
I just had one question.
Yeah.
And when it came to rounding to find x, the x value, you round according to the number, right? Doesn't have to round up.
So, yeah,
Okay.
we rounded to the nearest integer. So in this case, the nearest integer was 45. In this case, I think we rounded up again. I don't remember the exact number.
32.89 or something like that.
Yeah, so we're just rounding to the nearest integer.
So if it was 33.1, you would still round, I'm sorry, 32.1.
You'd round down to 32, correct.
Alright.
Yeah, 33.2, you'd round to the nearest integer, which would be 33.
I have one second question. Where exactly, because we learned to round up somewhere. In
Okay.
this- I don't know if
It was with
this
sample
section.
size. It was sample sizes.
Okay.
Sample size, you always round up.
Okay, thank you.
But other than that, one exception, you're just going to round to the nearest integer.
Okay, thank you.
All right. I think before class we chose to do a test of a couple movies. Before I get there, you've got an exam coming up next week. And I know that we've already learned a lot, but I think, let me see if I can't find it. A lot, I know. So there is one more thing that we're going to learn today. So if you think about distributions that we've dealt with, We dealt with the t-distribution, the chi-square distribution, the normal distribution, the binomial distribution. I want to add one more to that. So here's our normal distribution. I'm going to introduce to you the paranormal distribution. Ah, happy Halloween, yay!
I was about to get upset. No, seriously, I was wondering where my tomatoes was at.
She's like ready to take action. It's like, all right, I'm going to massacre your ratings on Rate My Professor.
Yeah, your percentage is about to drop this year.
Yeah, yeah. You've been saying that for a few semesters now.
Hey, I was just playing on those ones, but this one's for real.
This one's for real. This time's for real. All right. Let's,
You're no longer gonna
did you want to do the one on the handout, or do you want to do our own example of comparing the accuracy rates in the last couple of last Star Wars movies?
do our own. No one likes Star
Onto
Wars.
these? No one likes Star Wars? Wow.
I've heard so many gags.
I'm getting a lot of, people shaking their head at you. I don't know.
I could not tell you what happens.
I can't tell you a character in there.
Okay.
Stormtrooper.
All right. All right, tell you what. Fine. If you don't want to do the fun one, then we can do the really mundane one on the back of the handout.
Oh no, we don't want to do one on the
No, too late. Too late. All right.
I kind of read that over Star Wars.
Let me look at it up here. Make it a little bit easier for to see.
One for your class in costume. I thought that's what you
So,
He don't pay me no attention.
among 2,036 passenger cars in a particular region, New York, 221 had only rear license plates. Amongst 390 commercial trucks, 56 had only rear license plates. A reasonable hypothesis is that commercial truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. Now we got to be careful with how we set this up. To me, it makes sense to use P sub T for P sub trucks versus P sub C for passenger cars. You can use other things if you want. You can use P1 and P2. You just got to keep track of what is where. Now our original claim is right here, that truck owners violate laws requiring license plates at a higher rate than owners of passenger cars. Now let's think to ourselves for a second. Is this going to be a test about means, standard deviations, or proportions? It's all the above, right? All right. List three different answers. All right. So your proportions personality is the right one. This is going to be a test about proportions. But the reason I'm mentioning this now is because later on, when we've accumulated more hypothesis tests, you're going to have to look at this and decide, well, which am I testing? It's not saying anything about how spread out the data is or the variability, so it's not standard deviation. It's not a claim about a mean, but rates and proportions can be thought of as being more or less one and the same. So, yeah, this is going to be our original claim that P sub T is greater than P sub C. Now that has implications for how you set up your null and alternative hypothesis and how you enter your data. So first step, HO and HA. Second step, do they give us an alpha? Yeah, they use 10% again. I'm tired of 10%. It just never happens outside of a stat book. So executive decision, yeah, we'll go with 0.05. And let's keep track of some data here. For trucks, there was N equals 390 trucks, and of those, 56 of them violated the 2 license plate rule or law. And for cars, N was 2,036. And of those, there was 221 violations, like there. If it helps you out, you can actually find your P hat, P sub T hat, and P sub C hat. I think the first one is about 14%. The second one's about 10%. Maybe not quite 10%. Is it 9%? I don't know. It's just X sub T divided by
Okay, never mind.
N sub T.
Yeah,
Don't. All right, and let's see the other one. 221 divided by 2,036. All right, 11%. Somehow. Yeah, okay, yeah, all right, yeah. 0.11. So, but is this difference enough to give us a significant test? Well, we'll have to find out. The thing you have to be careful about is entering this into your stat disk. All right, so let's see. Who I picked on yet? Let's see. Okay, Matilda. Minion. What's HO and HA going to look like?
Okay, so the original claim is the alternative.
All right, so P sub T greater than P sub C. What goes in HO?
PT greater than or equal to PC.
Mm-mm.
Less than or equal to, I'm sorry.
Less than or equal to PC. Cool.
It's making me nervous. Sorry.
All right. So there's your original claim. Kind of circle that for later use. Now when you put this in, P sub T is going to be your first sample. So that's sample 1 data. And that's going to be sample 2 data. Let's go in and put those numbers in and get our p-value. So let's do that. Go back to hypothesis testing, proportion to samples. And let's see, where am I at? Nick, which one of these do I want for the alternative? 1, 2, or 3? 2. Yep, 2 works good. Significance level, I think we changed it to 5%. So trucks is going to go first, 390 over 56. And then 2,036 and 221. Great. So let's see here. So from right here, I need the p-value. P-value is 0.231. Yeah, right there. If you're getting 0.976 something, then you probably have the alternative hypothesis set up wrong. So, okay. Ashley,
Yeah.
what are we going to decide?
Do we fail to reject it now?
Nee, do you agree? Fail to reject H naught or reject H naught? Which one? Joy, we got an indecision here.
Reject.
Reject H naught.
Yeah.
So I've had a fail to reject, reject, and an indecision. So what is it? What is it as a group? What do you think?
It's rejected.
Reject H naught. Why? P is low, H naught must go, right? So we're going to get rid of the null hypothesis because the p-value is less than alpha. Let's state our conclusion in words. Let's first of all figure out which format we're going to use. Now you're free to go a little bit off script. I mean, that's fine, but you know, when your grade is on the line, I think I'd kind of stick closer to the script. So let's take a look at wording again. Try and decide for yourself which one you're going to use, A, B, or C. Yeah, it's looking like C. The original claim did not contain the possibility of equality, so we branch down to the right. And then we go straight to the right because we rejected H naught. So the data support the claim that trucks violate the two-plate law more often than owners of passenger cars. And let me switch over here. That trucks violate the law, and that is the two-plate law. More often than owners of passenger cars. Nicole? That's a fine way to do this. So a lot of times the original claim is going to be right there in the formulation of the question. If you want to just copy it right out of the original wording of the problem, that's fine. That's a very safe way to do these things. I got no issue with that. Other comments on this one? Let's take a look at, let's see, let's look at the confidence interval. Suppose we did a 95% confidence interval. One thing you might notice, because this is a one-sided test, your confidence interval doesn't necessarily match your significance level, does it? No. Significance level of 0.05 should go with a 95% confidence interval. There's two workarounds for that. One is you can go back up here and do a confidence interval. The other workaround is you can change the alternative hypothesis to be not equal to, and now it should give me a 95% confidence interval, which I think it will. There you go. So there's your 95% confidence interval. Now at the 95% level, this confidence interval says you're not going to reject H naught. Why?
Why?
0 is in that confidence interval. So, yeah, that would be a little bit of a problem. Because remember, your null hypothesis says that one of the possibilities is that these two things are equal. And if those two things are equal, then that's going to mean that P sub t minus P sub c should equal 0. That's one of the possibilities. So if your confidence interval contains 0, you should not be rejecting H naught. Now in the case when your confidence interval and your hypothesis test conflict, then you should get rid of, or then you should trust your hypothesis test. So I would stick with the hypothesis test on that one. I think it gets a little bit more tricky when you have a hypothesis test that's one-sided. So let's take a look at our confidence interval for that one. Proportion to samples, 95%. It should give me the same thing that I just had. So 390, 56.
I'm sorry.
I'm not so sure about that.
You know me so well.
221. There we go. So yeah, we're getting the exact same thing here. So here, it seems like our confidence interval is in conflict with the results from your hypothesis test. If that's true, go with your hypothesis test. I do remember talking to the author about that one time, and he suggested the same thing. Any last minute thoughts, comments on this one or anything from section 9.1? All right, let's put this one in the